Welcome back to my channel. My name is Rakshit Subramanya, a student studying at SVC. Today I am going to be talking about the topic Students T distribution, which is a topic in statistical interface from probability. So let's see. The student T distribution is a probability distribution used in statistical interface. It was developed by William Cayley Gossett, who wrote under the pseudonym student. It is commonly used when sample sizes are small or the population standard deviation is unknown. Here you can see a graph which will explain a little bit about the students' T distribution. Let's move on. Now let's know the characteristics of student T distribution. The shape of the student T distribution is similar to the standard normal distribution but with heavier tails. It is a symmetric distribution centered around 0. The degree of freedom is which is represented by df is a parameter that determines the shape of the distribution. Here you can see the photo, which is the standard deviation and the mean with the probability. It is a graph that is with respect to probability and the t-score, that is the number of standard deviation for the mean. So let's move on. Now let's see the degree of freedom, which is represented by df in students T distribution. The degree of freedom in students T distribution represents the small size minus 1. That is, it represents the small sample size minus 1. Sorry, that was I have corrected. The larger the degree of freedom is, the closer the T distribution approximates the standard normal distribution. So basically, the degree of freedom in students T distribution represents the sample size minus 1. So the degree of freedom is the sample size minus 1 in student T distribution. In that, where the larger degree of freedom is always closer or it approximates to the standard normal distribution, which you will be calculating while doing the sums. Now, as the degree of freedom decreases, the tails of the T distribution becomes thicker, which you will see here in the diagram. Do pause the video and see the diagrams. Calculating probabilities with the T distribution. The T distribution is used to calculate probabilities of obtaining a sample mean within a certain range. To calculate probabilities, we use a T-table or statistical software. The T-table provides the critical values for different levels of significance and degrees of freedoms. As you can see, all the different critical values and different degree of freedoms are provided here, be it the degree of freedoms being horizontal and the critical values being, degree of freedom being vertical and the critical values being horizontal. And you can see for everyone, while doing sums, you use this table to compare the values to see whether the hypothesis is accepted or not. So let's see the next one. So calculation of T values. T values are calculated using the formula T is equal to x minus mu by S into SQRT of n, where x is the sample mean, mu is the population mean, and S is the sample standard deviation, and n is the sample size. T-values are used to calculate confidence intervals and perform hypothesis tests. T-values can also be looked up in a table or calculated using statistical software. Here you can see in the right side the formula which we are going to use. It's a different one, but be sure to look into it. Now let's see confidence intervals with student's T distribution. The student's T distribution is used to calculate confidence intervals when the population standard deviation is unknown. The confidence interval provide a range of values within which we can be confident that the true population mean lies. The formula for the confidence interval is Ci is equal to x plus or minus t. So you'll have different sums ranging from different one where they ask you to find the degree of freedom, or you're going to be finding the confidence interval. There are many times which is 99% confidence level or 95% confidence level, or there are different ones. So 0.1% error or 5% error. So there are different ones. You will see it in the different sums. But this is the theory for the concepts. The hypothesis testing with student's T distribution. Student's T distribution is commonly used in hypothesis testing to determine if a sample mean is significantly different from the hypothesized population mean. So as I told you before, the critical values and the degree of freedoms are used in checking whether the hypothesis applies or not. So this is where you see that. They test the hypothesis whether it's close to your hypothesized population mean or not. So the null hypothesis assumes that there is no significant difference between the sample mean and the population mean. The alternative hypothesis assumes that there is a significant difference between the sample mean and the population mean. So let's see the next one. One sample T testing. One sample T test is used to compare the mean of a single sample to a known population mean. This test static is calculated as T is equal to x minus mu divided by S into SQRT of n, which we read as before, where x is the mean, mu is the population mean, and S is the sample standard deviation, while n is the sample size. The resulting T value is compared to the critical T value from the T distribution table which we saw before to determine if the null hypothesis should be rejected or accepted. One of the sample T tests. So one of the sample T tests used in the following situation are such as the size of a sample is less than 25 or the population standard deviation is unknown. That is where one of the one sample T test is used. The formula for one sample T test is estimated population standard deviation to calculate the standard error. So here in one you'll have standard error which you'll have to calculate the standard error, or you'll have to find the hypothesis testing, which is either done with the 99% error most of the times, but sometimes you have to do 95% error also. So here you will have questions with one sample, such as if you take a manufacturing etc, you can take only one company manufacturing compared to a population, while in 2T test you will have two companies manufacturing, so you will compare between both of them. So let's see two sample T testing. Here it is. A two sample T test is used to compare the mean of two independent samples. The test statics is calculated as T equals to x1 minus x2 divided by SQRT of, that is square root of s1 square by n1 plus s2 square by n2, where x1 and x2 are the sample means and S1 and S2 are the sample standard deviations, and the N1 and N2 are sample sizes. The resulting t-value is compared to the critical t-values and the t-distribution to determine if the null hypothesis is to be rejected or accepted. As I said, here in two sample t-test you compare two means of two sample independent. So if you take manufacturing, there's a company A, there's a company B. But while in the one sample t-test, there's only company A, that's all. Paired t-test. A paired t-test is used to compare means of two related samples such as before and after measurement on the same subject. The test statistics is calculated as t is equal to x dash d minus mu d divided by sd whole divided by sqrt of n, where xd is the mean of the differences, mu d is the hypothesized mean difference, and sd is the standard deviation of the differences, and n is the sample size. The resulting t-value is compared to the critical t-value for the from the t-distribution to determine the null hypothesis, which should be either accepted or rejected. Please do see the photo for more examples here. So let's move on. So in conclusion, the student t-distribution is a valuable tool in the statistical inference, especially when sample sizes are small or the population standard deviation is unknown. It allows us to calculate the confidence interval and perform hypothesized tests. Understanding the concepts and applications of the student's t-distribution is essential for making accurate statistical inferences. Hope you understood something in this video. Thank you.